Here's another exponential growth problem, but this, being a population of frogs, means that we should use the natural exponential growth formula. The p, the beginning amount, and then e to the RT. Only one small problem. In here it doesn't say what the rate is, so we're going to have to find that ourselves. So the starting amount of frogs, 24, is the p. The r is not known. The t is given because it's going from 2005 to 2009, so that's 4 years. And after the 4 years, the amount of frogs was 104. So now to solve for r, we're going to have to take natural log, but the 24 is in the way, so get it out of the way by dividing both sides by 24. And you could reduce the 104 over 24 if you want, but we're going to be taking natural log of it in just a moment, so you can just leave it that way as well. So the next thing to do is use the opposite of the exponential function, which is the natural log function. Do that on both sides. And these are going to cancel, leaving just the exponent r times 4. And on this side we have the natural log of a fraction, 104 divided by 24. And then to solve for r, just divide by 4. So it's going to be the natural log of a 104 divided by 24, and then divide that whole thing by 4. So the natural log of 104 divided by 24, and when that's done, divide the answer by 4. So they're growing at about 36.7% per year. 367. So r is equal to 0.367. That means that in general the function is the beginning amount of frogs will always stay there, and then e to the r t. Now if we were only asked for the function, we would be done. But in this one I'm asking for a little more work, and that is now use that function and find out when are there going to be more than 200 frogs. So this time use a 200 for the amount of frogs, and then we've got 24 e to the 0.367 t, and now solve for t. The work's basically the same as this, so we can divide by 24, 200 divided by 24, that isolates the e, and then to eliminate the exponential function, use natural log. Once these are gone, we would then have 0.367 t, and on this side the natural log of the fraction 200 divided by 24. And now divide both sides by the 0.367, and then we'll have the time. So the natural log of 200 divided by 24, close the parentheses, and divide by 0.367. 5.777 years later is when there's going to be 200 frogs. So moments after that, it's going to exceed 200 frogs. But we now need to find the year and the month. Well, this is saying 5 years later from the start of the story. So that means that it's 2010. So 2010. And now that we're done with the 5, use the 0.777 So it's basically saying 77.7% of a year. And since a year has 12 months, multiply by 12, and it's going to be the 9th month. So that would be September. And if you even want to know the day, you can just take the decimal part, 0.324, and multiply with how many days are in September, and it would be the 9th, September 9th.